November 12th, 1912. A search party moves slowly across the Ross ice shelf, looking for 3 men they already know are dead. They find a shape in the snow that does not belong to the landscape. A low mound, too regular, with the tip of a tent pole breaking the surface. They dig. Inside the tent are 3 frozen bodies, and beside the bodies, lashed to the sledge those men had been dragging by hand for hundreds of miles, sit 35 pounds of rock. The men had been starving when they died. For weeks they had been hauling that sledge across a continent that was killing them, and somewhere in those final days, too weak to carry their own gear, they made a decision about what to abandon and what to keep. They kept the rock, and pressed into the surface of one of those stones was the fossilized leaf of a plant that has never grown in Antarctica, could never grow in Antarctica, unless Antarctica had once been something no one in 1912 was prepared to say out loud. There is a landscape in East Antarctica that no human being has ever seen, and no human being ever will. It is roughly the size of a small country, by one published estimate around 30,000 square kilometres, comparable to the area of Belgium. It has river valleys. It has ridges standing between those valleys, the long rounded divides that form only when running water spends millions of years patiently cutting the low ground away and leaving the high ground behind. It has the unmistakable fingerprint of a warm, well-watered, vegetated terrain, the kind of land where rivers braid toward a coast and forests hold the slopes together, and every square metre of it is sealed beneath more than 2 kilometres of solid ice. In 2023, a geographer at Durham University named Stuart Jameson, working with colleagues in Britain, published the description of this place in the journal Nature Communications. They had not drilled down to it. They had reconstructed it, from satellite measurements of the ice surface and from radar pulses sent down through the ice sheet, pulses that bounce off the rock at the bottom and come back carrying the shape of the ground. When they assembled those echoes into a map, they were not looking at a frozen wasteland. They were looking at hills and valleys carved by water, a terrain shaped by rivers and then, at some point, simply switched off, frozen mid-sentence. The researchers concluded the landscape had been preserved, untouched, for at least 14 million years, possibly for 34. Think about what that means. Somewhere under the most lifeless surface on the planet, there is a river country with its valleys and its watersheds still intact, held in the dark and the cold like a photograph that was taken and never developed. Antarctica is not a frozen continent. It is a green continent that froze, and the green is still down there. To understand what was lost, you have to stop picturing Antarctica as a place and start picturing it as a moment. For most of the time it has existed, the landmass we now call Antarctica was not at the bottom of a frozen world. It was the keystone of a supercontinent. Geologists call that supercontinent Gondwana, and for hundreds of millions of years it held South America, Africa, India, Australia, and Antarctica locked together as a single body of land. Antarctica sat in the middle of it, not the edge, the middle. The other continents were arranged around it the way petals are arranged around the centre of a flower, and across all of them stretched the same forests, the same swamps, the same rivers, because there was nothing to separate them. We know what grew on that land because we have held it in our hands. The dominant plant of Gondwana, through the long stretch of time geologists call the Permian, was a seed fern named Glossopteris. It was not a small thing. Glossopteris grew into trees, woody trunks, broad tongue-shaped leaves, whole forests of them blanketing the southern half of the planet. Their fallen leaves built up season after season, year after year, for millions of years, and were buried and compressed and turned into coal. There are coal seams in the transantarctic mountains today, thick, black, unmistakable beds of compressed plant matter running through the rock of the coldest desert on Earth. Coal does not form in ice. Coal forms where things grow, die, pile up, and rot in warm, wet abundance. The presence of coal in Antarctica is not a curiosity. It is a verdict. It says plainly that this place was once a swamp forest, that the forest was vast, and that it lasted long enough to leave a layer you can still set on fire. And these were not ordinary forests. Look closely at the fossilized wood that geologists have pulled from the transantarctic mountains, and you find growth rings. And the rings tell a story that should not be possible. Even when Antarctica was warm, it was still at the bottom of the world, which means it still spent months of every year in total darkness. Polar night does not care about temperature. The trees of ancient Antarctica grew in a place that was mild and wet and green, and that also went black for a third of the year every year. The growth rings show the trees shutting down for those months and surging back when the light returned. There were forests on this planet that learned to live through a winter with no sun at all. They did it for tens of millions of years, and then we lost not just the forests, but the very memory that such a forest was ever a normal thing for the Earth to produce. It was not only plants. In 1991, a team working on Mount Kirkpatrick, a peak in the Transantarctic Mountains, more than 4,000 metres above sea level, a few hundred miles from the South Pole, cut into rock from the early Jurassic, and found the bones of a predatory dinosaur. It was a meat-eater, around 6 or 7 metres long, and it had a strange thin crest of bone standing up across the top of its skull like a comb. The paleontologist who described it, William Hammer, named it Cryolophosaurus, the cold-crested lizard. The newspapers, noticing the pompadour-shaped crest, called it Elvisaurus. But the joke obscured the real point. A large dinosaur cannot live on an ice cap. It cannot feed itself, cannot regulate its body, cannot exist in a place that is frozen solid. Cryolophosaurus was found near the South Pole because, in its lifetime, the South Pole had forests and rivers and prey and seasons. Closer to our own era, the picture only gets stranger. In 2020, and I will return to this study, because it is one of the most important pieces of the whole story, a team led by a geologist named Johann Klages at the Alfred Wegener Institute in Germany recovered a sediment core from the seabed off West Antarctica. Buried in that core, beneath layers of ocean mud, was a dense network of fossilized plant roots, still in the soil they had grown in, along with preserved pollen and spores. The team dated the material to roughly 90 million years ago. They reconstructed the environment it came from. It was a temperate rainforest, swampy, dense, green, and it had been growing within about 900 kilometers of the South Pole. The mean annual temperature, they estimated, had been around 12 degrees Celsius, mild, wet. The kind of climate you would associate today with a forest in New Zealand, not a polar ice sheet. 900 kilometers from the pole, a rainforest. This is the world before. Not a fringe theory, not an internet rumour. The settled, published, repeatedly confirmed deep history of the continent. For the overwhelming majority of its existence, Antarctica was a living, growing, forested land. The ice is not the rule, the ice is the exception, and the exception is astonishingly young. So what happened? And why does almost no one carry the answer around in their head when they can tell you instantly that Antarctica is the coldest place on Earth? The physical turn has a date, or close to one. Around 34 million years ago, at the boundary geologists call the Eocene-Oligocene transition, the planet crossed a threshold. The amount of carbon dioxide in the atmosphere, which had been high for tens of millions of years, fell. As it fell, the world cooled, and at the same time, the map itself was changing. South America and Antarctica, which had been joined, were pulling apart. The gap between them, the stretch of ocean we now call the Drake Passage, opened wide enough and deep enough for a current to pour through it. That current is called the Antarctic Circumpolar Current, and once it formed, it did something no other current on Earth does. It runs in an unbroken ring all the way around Antarctica, with no landmass to interrupt it. It became a moat, a wall of cold, circulating water that wrapped the entire continent and cut it off from the warm currents that had been reaching it from the north. Thermally isolated, starved of warmth, sitting under a falling carbon dioxide sky, Antarctica did what no continent had done in a very long time. It began to grow an ice sheet, and once the ice started, it fed itself. White ice reflects sunlight. Reflected sunlight means less heat absorbed. Less heat means more ice, until a forested continent became the frozen one on your classroom map. I should be honest here. Scientists still argue about exactly how much of that freezing to assign to the falling carbon dioxide and how much to the opening of that ocean gateway. That part is genuinely unsettled. But the outcome is not in dispute. A green continent went white, and it happened fast. That is the physical turn, and the science behind it is solid. But there is a second turn in this story, and it is not geological. It is human. It is about what happened to the people who found the evidence, and what was done to the truth they were holding. Go back to those 35 pounds of rock on the sledge. The men who hauled them were the polar party of Robert Falcon Scott's Terra Nova expedition. They reached the South Pole in January 1912 and found that the Norwegian Roald Amundsen had beaten them to it by a matter of weeks. They turned for home, 800 miles of it, and the ice took them one by one. On the return, passing a place called Mount Buckley near the Beardmore Glacier, the expedition's doctor and naturalist Edward Wilson spent part of a precious day chipping plant fossils out of the rock. The men were already in trouble. They were short on food and short on time, and still they added rock to the load and kept dragging it. Scott kept a diary to the end. Standing at the pole, beaten and exhausted, he wrote a line that has been quoted for a century. "Great God, this is an awful place." He died snowed into a tent around the end of March 1912. The search party found him, Wilson, and Henry Bowers in November, with the fossils still on the sledge. The rock went back to England. A paleobotanist at Cambridge examined the leaves Wilson had collected and identified them. They were Glossopteris, the same tongue-shaped leaf found in South America, in South Africa, in India, in Australia. A plant that linked 5 continents into one ancient forest, and now Antarctica was confirmed as part of it. Here is where the story stops being about ice and starts being about how knowledge is allowed, or not allowed, to mean what it means. In the very same years, 1912-1915, a German scientist named Alfred Wegener was assembling exactly the argument those fossils demanded. He looked at the matching coastlines of Africa and South America, at the identical rock formations on opposite shores of an ocean, at the distribution of fossils like Glossopteris that made no sense unless the continents had once been joined, and he proposed that they had been joined, that the continents move. He called it continental drift. He was not vague, and he was not careless. He had the fossils, he had the rocks, he had Scott's own samples as part of the picture, and the scientific establishment of his time did not merely disagree with him. It ridiculed him. The stated reason was respectable enough. Wegener could not explain the mechanism. He could not say what force was strong enough to push continents through the crust of the earth, and without a mechanism, his critics said, the idea was not science. That was the stated reason. The deeper reason was that continental drift, if true, meant almost everything had to be re-examined. Every map, every assumption about a fixed and finished planet. Geology had settled into a comfortable picture of a stable Earth, and Wegener was telling them the ground itself was provisional. It was easier to call him an amateur. He was trained partly as a meteorologist, and the word was used against him like an insult. He died in 1930 on the Greenland ice sheet, on an expedition, with his great idea still officially rejected. It took until the 1950s and 1960s, until the discovery of seafloor spreading gave drift its missing mechanism, for the establishment to admit that the mocked amateur had been right about the largest single fact concerning the surface of the planet. He had been right for 50 years before they said so, and the fossils that had been trying to tell everyone the same thing sat, correctly identified and quietly filed, in a museum drawer. Let me lay the evidence out in one place, because each piece has been independently established, and together they do not leave much room for argument. Start with the fossils themselves. Glossopteris specimens collected by Scott's expedition are real, catalogued, and held in British collections to this day. They were examined and identified by a professional paleobotanist within a couple of years of the men's deaths. This is not a story that depends on interpretation. The leaves are physical objects. They were carried out of Antarctica by men who died doing it, and they say one thing: forests grew here. Add the coal. The Transantarctic mountains contain extensive Permian coal beds, thick seams of compressed plant matter, hundreds of meters of sedimentary rock recording swamp after swamp after swamp. Scott's own men noted coal during the expedition. Coal is not ambiguous. It is fossil sunlight stored by plants, and it does not exist where plants cannot grow. Add Cryolophosaurus, the crested predator from Mount Kirkpatrick, described by William Hammer in the mid-1990s, an early Jurassic dinosaur recovered a few hundred miles from the South Pole. Add the fossil forests of petrified wood that geologists have documented at multiple sites across the Transantarctic range, tree stumps still rooted where they grew. Then add the 2020 study, because it is the one that should have rewritten everyone's mental image of the place. Johann Klages and his team at the Alfred Wegener Institute published their findings in the journal Nature, a 90-million-year-old temperate rainforest, its root system still intact in fossil soil, recovered from beneath the seabed off West Antarctica, within 900 kilometres of the pole. Mean annual temperature around 12 degrees. The study did more than confirm that Antarctica was once green. It forced a recalculation of how much carbon dioxide the Cretaceous atmosphere must have held, because nothing else could keep a polar forest that warm. Now the strangest piece, the one that behaves like a timeline that does not add up. Under the ice of East Antarctica, beneath the high dome the maps label Domia A, there is a mountain range. It is called the Gamburtsev Subglacial Mountains, and it is roughly the size of the European Alps, with peaks rising thousands of metres, and it is buried under as much as 3 to 4 kilometres of ice. No human eye has ever seen it. A Soviet expedition first detected it, to general disbelief, in 1958. During the International Polar Year, in 2008 and 2009, a multinational project flew aircraft loaded with radar, gravity meters, and magnetometers in grids across that region of the continent to map the range properly. What they found is the puzzle. The Gamburtsev Mountains are old. Their roots reach back hundreds of millions, possibly more than 1 billion years. A mountain range that old should be a worn-down stub. Erosion is relentless. Given enough time, it grinds any range flat. The Appalachians, far younger, are gentle hills. And yet the Gamburtsevs, under the ice, still have sharp alpine peaks and deep valleys. Jagged, young-looking. As if the clock stopped, and the clock did stop. The leading explanation is that these mountains were where the East Antarctic ice sheet first formed, around 34 million years ago. The ice nucleated on those high peaks, then thickened and spread, and in doing so it sealed the mountains inside itself. The ice that buried the range also protected it. It stopped the erosion mid-process and preserved a 34-million-year-old mountain landscape, complete with the river valleys that had been cutting into it right up until the moment the cold arrived. The Gamburtsevs are not just mountains. They are a frozen snapshot of the exact transition, the last green moment, sealed under the first ice, and the land under the ice is not even fully frozen. Radar surveys have mapped more than 400 lakes of liquid water trapped beneath the Antarctic ice sheet, actual lakes, kept liquid by the pressure of the ice above them and the warmth of the rock below. The largest, Lake Vostok, lies under nearly 4 kilometres of ice, and is comparable in size to Lake Ontario. It has been sealed off from the sky for millions of years. Whatever the continent was before the ice came down, it did not simply die and go still. Underneath, in the dark, there are mountains and canyons and river valleys and hundreds of hidden lakes, a whole secondary geography that the ice covered but did not erase. Add to that the 2019 mapping project called Bed Machine Antarctica, led by Mathieu Morleghem, which assembled the most detailed picture yet of the rock surface hidden beneath the entire ice sheet and revealed, among other things, the deepest land canyon on Earth, a trench beneath the Denman Glacier reaching some 3.5 kilometres below sea level. And add the 2023 buried river landscape that opened this story. Together, these surveys are doing something remarkable. They are slowly recovering the face of a continent. Not the ice, the land under it. And the land under it is not a featureless slab. It is mountains and canyons and river valleys. The geography of a place that lived. Now the fair counter-argument, and I want to give it honestly. Someone reasonable will say, none of this is hidden. Deep-time geology is a real field. The fact that Antarctica was once warm and forested is in textbooks. Continental drift is not suppressed. It is the foundation of modern Earth science. Gondwana is taught in schools. So where exactly is the erasure? And that objection is correct on its own terms. There is no locked vault. No agency stamped this secret. Every paper I have cited is public. But here is what the objection misses, and it is the same thing it always misses. A fact can be technically available and functionally erased at the same time. Ask any adult to picture Antarctica. They will picture white. They will picture penguins and a flat horizon of ice, and the idea, absorbed so early it never gets examined, that this is simply what the place is and always was. The truth, that the ice is barely 34 million years old, that for hundreds of millions of years before, that the continent was forest and river and swamp and dinosaur, that the green is the long story and the white is the recent interruption, that truth exists in the literature and almost nowhere in the public mind. Nothing buried it. A picture did. A map on a classroom wall that shows the present and quietly implies the present is permanent. That is a softer kind of erasure than a fire in a basement. It may also be more complete. I sat with this for a long time before I could find the right way in, and the thing that held me up was not the science. The science is generous. It practically hands itself to you. What held me up was a single image I could not get out of my head. 3 men in a tent, starving, frostbitten, certain by then that they were going to die. And among the last decisions they made, with whatever strength was left, was the decision not to lighten the sledge by leaving the rocks behind. I kept asking myself why. They were not going to publish anything. They were not going to be rescued. They had to know that adding 35 pounds of stone to a load they could barely move was, in pure survival terms, close to insane, and they kept the rocks anyway. The only explanation that holds is that Edward Wilson, looking at those tongue-shaped leaves in the rock near the Beardmore Glacier, understood what he was holding. He understood that those leaves were a message, that this killing white desert had once been warm and alive, and he decided that the message was worth more than the weight, that it had to get home even if the men carrying it did not. It got home. They did not. And then it sat in a drawer while the establishment spent 50 years mocking the man whose theory those exact leaves confirmed. That is the point where this stopped being a geology story for me. That is the point where it became something else. Because the pattern here is not about ice. It is about what a civilization does with a fact that is too large to comfortably hold. Look at the shape of it. The evidence arrives. Fossils, coal, dinosaurs, a rainforest, a buried country with rivers in it. The evidence is unambiguous. It is collected, sometimes at the cost of human life, by people who clearly grasp that it matters. And then the system absorbs it without letting it land. It identifies the fossils correctly and files them. It lets Wegener be right in a journal and wrong in every room that matters for half a century. It puts Gondwana in the textbook on page 200 and leaves the mental image of eternal white Antarctica completely intact on page 1. The fact is admitted, the implication is declined, and the implication is the part that should keep you up. Because if Antarctica, the most permanent-looking thing on the entire map, the white anchor at the bottom of every globe you have ever spun, is in fact a recent and temporary condition, then permanence itself is the illusion. The continent was forest far longer than it has been ice. The ice is the new arrival. The map is not a description of how things are. It is a photograph of a single instant in a process that never stopped moving. Run the arithmetic because the arithmetic is the whole argument. The Earth is about 4.5 billion years old. The Antarctic ice sheet is about 34 million years old. That means the ice has existed for less than 1% of the planet's history. For more than 99% of the time there has been an Earth, there was no permanent ice cap at the South Pole at all. The thing you were taught to treat as the very definition of cold and permanence is, on the planet's own calendar, a recent event still in progress. Once you see that, you cannot unsee it. You start to notice that the same move has been made everywhere. The coastline you think of as fixed is a tide mark on a moving target. The river that defines your county once ran somewhere else. The familiar map is a freeze frame sold to you as a final still. And nobody had to organise this. No committee decided you should believe the world is finished. It is simply easier to teach, easier to picture, easier to live inside, to treat the current arrangement of the planet as the natural and permanent one. The comfort does the work that no one ever had to coordinate. That is why the green continent stays hidden in plain sight. Not because the data is locked away, because the data asks too much. It asks you to accept that the ground is provisional, that the poles are temporary, that the white at the bottom of the map is a chapter and not the book. Most people, most institutions would simply rather not. So the fossils stay in the drawer, the rainforest study gets one news cycle and fades, the buried river valleys make a headline and vanish, and the classroom globe keeps spinning with its permanent, eternal, never-questioned cap of ice. It is down there right now, a landscape with valleys, a country with rivers, forests turned to coal you could light with a match, and it is all underneath, waiting, while we point at the white and call it Antarctica. The leaves Edward Wilson chipped out of the rock near the Beardmore Glacier are still in Britain. You could, in principle, go and stand in front of them. Tongue-shaped, pressed flat, 90 million years older than the men who carried them, and outlasting those men by more than a century already. I keep returning to the tent. to the search party in November of 1912, digging down through the snow, lifting the canvas, finding the 3 frozen bodies, and finding beside them the rocks they would not put down. We tell that story, when we tell it at all, as a story about heroism and tragedy and the cruelty of the ice. We almost never tell it as what it also plainly was. The moment 3 dying men decided that a piece of evidence about the true history of the Earth was worth more than their last reserves of strength. They were right. The evidence was that important. It confirmed that the continent killing them had once been green, had once been warm, had once been part of a single forest stretching across 5 of the world's land masses. And the world took that evidence and identified it correctly, and then declined to be changed by it for 50 years. So here is what I am left with, and I do not have the end of it. If a fact this large, a forested polar continent, a green world under the white one, can be technically known and functionally forgotten for a century, what else is in the drawer? What other evidence has been carried home at terrible cost, catalogued, shelved, and quietly allowed to mean nothing? How much of what we call settled is just unexamined? And why is it that the things hardest for us to absorb are so often the things that were paid for in full by someone who never made it back? Antarctica was green. The men who proved it never came home. The proof outlived them, and we still have not really let it in. The ice is not the story. The ice is the interruption, and the green is still down there, under 2 kilometers of it, holding the shape of its rivers, waiting for someone willing to call the continent by its older name.